Hello, this is Marianne Vertiflor. This is for Microbiology 225 for Zusa Pacific. Today we're talking about the lab video for the bacterial morphology and staining techniques. So the different staining techniques, let's see, the morphology of a bacterial cell is defined by its shape, size, and arrangement. However, when you view bacteria through a microscope, it's often challenging, so there's different techniques to identify the bacteria. So staining increases the contrast between the cells and their backgrounds. A variety of staining techniques exist, including simple stains and differential stains. So for a simple stain, one dye is used to directly stain the bacterial cell or background. And the cell shape, size, and arrangement may be determined by simple staining techniques. For a direct stain, it's a type of simple stain too, so only the bacterial cells become colored, leaving the background or external environment clear or colorless. And then moving on to negative stains. For negative stains, it's a type of simple stain. The cell is actually unstained and appears as a bright, often colorless object against a dark stained environment. For a differential stain, there's two or more dyes used. Cell morphology can be described and identified of the structural components of it. Okay, and then let's see. So moving on to gram-stain, gram-positive and gram-negative stains. So for the gram stains, it uses two dyes to distinguish gram-positive and gram-negative bacteria. Like simple stains, differential stains can provide information on cell morphology such as shape, size, and arrangement. For gram-positive cells, they have a thick outer cell wall composed of a mesh-like polymer called peptidoglycan, adjacent to an anterior plasma membrane. So that's for the gram-positive. And for the gram-negative, so for gram-negative cells, they have a thin cell wall comprised of a single layer or sheet of peptidoglycan sandwiched between an outer and inner cell membrane. The thin cell wall is only cross-linked in one dimension, and then for that too, the size of the cell wall of a gram-stain negative cell ranges from 2 to 8 nms in thickness. So that's it. Let's go move on to the slides. Here we go.
Okay, so I labeled the first slide because we're going to be doing a direct stain from a sample from your mouth, and it's the first slide. So I already vigorously scraped the inside of my teeth and gums with the sterile swab. So I'm just gonna flip it on slide. You're just gonna let it dry a little bit. Okay. Give me a couple seconds to dry. Okay, here we go. Passing it around 5 times. Okay. You're just heat fixing the sample. So we're supposed to let it dry for 10 minutes.
Alright, so it's been 60 seconds.
Just gonna wash it a little bit. Okay, so now we're ready to view it on the slide. Here we go. Okay, so we just started for the direct stain of the mouth, first slide, and right away, using the high power lens, I got a good view. I don't know if you can see. Oh yeah, there you go. Oh, for a second. Okay. So high power lens for the direct stain of the mouth. Okay, so starting the differential stains. So I have the inoculation loop, the alcohol for 30 seconds. Just letting it dry. So I'm going to start with the S. cerevisiae. As you can see, we have a lot of brie at the bottom. Try to do everything with one hand. Oh. Oops, got a little too much there. Placing it on the slide. Okay, so adding the last one, number 4, the saffron, 2 to 3 drops. Okay, you're gonna wait 30 seconds. I'm gonna rinse it, and then we'll let everything dry completely. Okay, so 2 for 2. I already viewed the S. cerevisiae, and I best saw the image with the high power lens, and now we're doing the S. epidermidis, and it's the same thing, and it looks best with the high power lens. Let's see if we can try to see. Oh yeah, you can kind of see it.